Hello, good evening, everyone. So, welcome to the session on analysis of project turbine, wind turbine failure. We are going to give you the project explanation. What was the business problem? How we have deal with this problem? We will provide the high level solution for this particular business problem. Our client was one of the leading green power generation companies. Okay. And our business problem here was unplanned failure of wind turbine engines, which is leading to huge losses and negatively impacting the electricity generation. Like cost of unplanned downtime. For example, if every minute a turbine is offline, which will translate to lost megawatts per hour as in revenue, plus exceeded repair cost. Unplanned failures can run into thousands of dollars per incident. So modern turbine generates hundreds of sensors reading like vibration, temperature, pitch angle, power output every 10 minutes. Manually combining this through this particular volume to find every warning sign is impossible. Like how the vibration, what is the temperature, what is the pitch, every 10 minutes. It is manually identifying it as a very tedious task. Okay. And hence, we will understand about what are the different or what are the common failure types here. What are the different common failure types which can occur in wind turbines, specifically for wind turbine engines. So here, there can be a gearbox wear. There can be a blade damage or a crack in the blades. There can be a generator overheating issues. There can be a pitch control system faults. There can be an electrical imbalance between them. That is why the issue may arise. Okay, so this is what our business problem is. And our business objective here is to minimize the unplanned failure. Okay, so what is the business constraint? So here is to maximize the power generation. Maximize the power generations from here. Okay, so these are our success criteria. Now, business success criteria is to reduce the unplanned failures of wind turbine engines by at least 30%. Machine learning success criteria, which is to achieve accuracy at least 85%. Economic success criteria, which is to achieve a cost saving of at least $2 million per year due to reductions of unplanned downtimes. So this was our data type. This was our data description. These are all the columns and the descriptions and how our units for particular data type. Okay, and here as you can see the failure status here, which is our output label or output target variable, which is failure or no failure. Whether due to this particular scenario or whether due to this columns, our model will going to fail, our output or our wind turbine or our engine is going to fail or not. Okay, so 0 here is signifies no failure and 1 signifies a failure. So this is a categorical like classification problem since it is a categorical output. Two classes. Okay, so here we will understand about the architecture diagram. This is a high level architecture diagram. Here, as you can see, we are having a business and data understanding. We will craft a project charter that lays out objective. For example, here it is to reduce the unplanned turbine downtime by at least 20%. Here our success criteria is 90% failure prediction should be there or it should recall. Then a data source and compliance requirement should be met. So this is what our project charter is. Then quality gates. Quality gates should be at each stage to ensure data integrity, model explainability. Why? Because of which factor our model is giving this output. And obviously, our reproducibility. Okay. Then we are having a data pipeline or automated data pipeline. Here, we are having an ingestions. Like we will have our data, the raw data which we will feed it into a CSV, which can be in a CSV or which can be in a REST API format. And into that, we are saving this into our S3, AWS S3. Okay, so we are saving it as a raw bucket, which is partitioned by a turbine ID and a timestamps. Then all these pre-processing things like we are having, if the data type is big, we can use our PySpark or we can use our pandas library for data pre-processing steps. We will clean our data, like we will clean and impute the missing values if there is certain missing values present or not. For checking the attribute if there is certain outliers are present or not, aligning with the timestamp data set. Then feature selections. We will select whether it is a rolling vibration means, what is temperature delta, etc. Then we will split the data into training and testing. Write all the curated artifacts into the S3 curated buckets. We'll again going to see the S3 curated bucket and store all the artifacts here. After that, we will have a model development or model training. Along with model training, we will also have a model evaluation. So here, as you can see, we can have multiple pipeline. We can create a model building pipeline over here, which will consume the curated data, trains the candidate algorithm. Like we can use multiple algorithm. We can use our random forest, XGBoost, various machine learning algorithms are there. At least try with 5 to 6 models, and from there, which model is giving you the better accuracy, we can choose that particular model. We will see the log matrix like confusion matrix, precision, recall, ROC curve, then F1 score to be a metadata store, and promotes the best model to a S3 location or standing S3 location. We will schedule the scoring and reporting, wherein we will have a batch scoring, a scheduled workflow. Okay, here we will fetch the latest 24 hours of sensor data. Okay, and we will run the feature engineering, which will invoke the models API, which will write the predictions to an S3 predictions. And or we can use it for like different purposes. After training our model and evaluating our model with the different scores, since we are having a classification problem here, so we can use F1 score, we can have an accuracy as a matrix, we can have precision, recall, all these as an accuracy. Okay, as a matrix, evaluation matrix. Then we can deploy this particular model on, either we can deploy this model on a Streamlit or a Flask application, or we can deploy by using a fast API, or we can deploy it by using it Dockers or Kubernetes and multiple other. Okay, so here as I have written, we will first going to make a Streamlit applications over here. Okay, so by using a Streamlit application, what we are going to do? Streamlit dashboards for the engineers to review the anomaly scores and feature importance explanation between them. We can also have a BI integration between them. Like we can predict and summarize in Power BI for executive reporting. We can also have an automated report generations, which can be in the form of PDF or a CSV, which is dropped into the S3 and mailed to the stakeholders directly from them. Okay, continuous improvement and governance. What it signifies means here we will have a monitoring and maintenance part. So if the model is having a drift, like model drift, say, for comparing a predicted failures to the actual downtime events to detect the model is drifting or not. For that reason, we will have a continuous monitoring and maintenance over the deploy. Even after deploying the model, we have to continuously monitor that particular thing. Then retraining the loops. If there is certain drift over the model, we have to retraining the loop. Monthly retraining pipeline will incorporate newly labeled data and phrases in the updated model, while preserving the order trials as well. Okay, so here we can make our monitoring as well as retraining loop also. So here as you can see, First, we have understood about the project charter. Project charter is nothing but we will ensure that the agreed goals or timeline and the success matrix should be there before any code is written. Okay, before any code is written, we should ensure that all the goals, timelines, and success matrix should meet. Then in the data collection part, we will have a SCADA dump into the S3 so that the large volumes are injected reliably. And data pre-processing, which will automate all the cleaning and feature engineering part. Okay, like no manual Excel steps and other things will be required. So all the automating will be happening on the data pre-processing part, wherein we will see all whether it is having outliers, whether it is having missing data, all these things, normalizing the data, all these things will be happening here in the data pre-processing part. We can have an auto EDA libraries, auto ML libraries for inspection purposes, like which model will suit here better. Model building and evaluation parts are fully reproducible with every matrix and dataset versions tracked. Then there is a deployment packages. The chosen model as a Docker based fast API services. Okay, we can use a Docker for deployment part. First, we have to use it the fast API key, and then we can use this Docker for the deployment purposes. Likewise, we can have our multiple things. We can make a report. We can send the report directly to the client directly by deploying, and then we will have a governance. So here in the governance, we are using a crisp MLQ quality gates and automated retrainings, which will keep the accuracy, explainability, and auditability intact. So for all these reasons, we will have we will adopt all these things into the okay collection of data from data of business and data understanding till monitoring and maintenance part. So this is the altogether project explanation of our project, which is wind turbine failure. Now, what we offer? What we offer means we are having challenging real-time projects that push you to your limits. We are having a real-time projects. Learning all phases of project methodology. Learning about different tools in the industries like Python, Power BI, cloud platforms like Kubernetes, Dockers, AWS, etc. Works on research papers that are published in international journals, and access to various free tools to enhance your learning. So these are, along with this, we are having a mind map, we are having animated series, we are having a resume optimization hub. All these things are there. Okay. This is our contact number. You can call us. We are having our branches in Hyderabad, Bangalore, and Chennai. Along with this, we are also having our branches in the franchisee partners in Pune, then Bhilai, and now in Noida also, etc. Okay, so you can call us, you can have an inquiry about us. Okay, thank you for joining, guys. We'll meet in next topic with the new topic in the next lecture. Thank you for joining.